Alright, good afternoon everybody. Today we want to talk about solving systems of equations. We want to talk about more than what we've talked about before, and we want to solve systems of equations where we have three variables. In order to solve for three variables, we're going to need three equations. What I like to do is I like to label my equations. So I'm going to label the first one A, the second one B, and the third one C. Now that we have A, B, and C, we want to start trying to eliminate some variables. So we're going to use A and B and we're going to eliminate Y. You can use substitution here, but I think elimination is going to be a lot easier to work with in the end. I picked Y because we can see here that we already have minus Y and plus Y in our equations. When we add these two together, we're going to get X plus 3Z is equal to 18. Now that we've gotten rid of one variable, we've solved for two. Now this is something we should feel a little more comfortable with. Now, we want to do that with B and C next. So we want to use B and C to eliminate. Once again, we're going to choose Y. When you do these, you want to eliminate the same variable in all equations so that we can get two variables that we can work with again. Once again, we can just add B to C. And this is going to give us 2x plus 0y. We've got our plus y and our minus y here. And plus 3z is equal to 21. Now, we've made two new equations that we can work with, only solving for x and z. Let's call the first equation we made, let's call it D. That would be next in the alphabet. And we'll call this one E. Next, we want to use D and E and we want to solve for either X or Z. Now, if we want to add these together, we have x plus 3z is equal to 18, and we have 2x plus 3z is equal to 21. Now, you could use substitution or elimination here to solve for either x or z. I'm going to use elimination. what I want to do is I want to multiply this equation by -1. This will get my z's to cancel out. So the equation we're going to be working with is -x minus 3z is equal to 21. Now when we add those together, we're going to get that x is equal to, lost a negative here, that's alright, we want that to be -21, or -18. So we get that x is equal to 3. Just like we did before, now that we've got our x, we can substitute that back into one of our equations, and we're going to get 3 plus 3z is equal to 18. To solve for z, we subtract 3 from both sides, and we get that 3z is equal to 15. And we get that z is equal to 5. So now we've solved for x and z. And now our last step is to solve for y. So we go back up to one of our original equations, either a, b, or c. And now we want to use either a, b, or c to solve for y. Now I think it's going to be a little easier if we use z, or equation b. So let's get to a blank page here. So if we've got -x plus y plus z is equal to 3, and we know that x equals 3, and we know that z is equal to 5. Now we just simply can plug our values for x and z into our equation. So we get -3 plus y plus 5 is equal to 3. Simplify that, we get y plus 2 is equal to 3. So y equals 1. Just like we did before, we want to write this instead of an ordered pair. This is called an ordered triple. When we write an ordered triple, if you guys haven't seen this before, what we do is normally our ordered pair is going to be written as x comma y. So we're going to keep that the same, and then we just want to add in z at the end. So finally, our answer we're going to write as 3, 1, and 5. I know this was a quick example. We'll go through more examples in class, but at least now you guys have somewhat of an idea when it comes to solving systems of equations with 3 variables.